Welcome to SERVOsoft, the optimal solution. This tutorial helps you learn about all things related to cycle time, including how cycle time is calculated, what happens when an axis sequence is different than the cycle time, and how cycle time is used in calculations such as motor RMS torque. Let's begin with where cycle time is displayed, which is on the main form power view. There's only one cycle time for a power group, and this is it. In the Pro version, there can be more than one power group. For all other versions, there's only one power group and therefore only one cycle time. Cycle time modes are auto and manual. The default is auto mode. Auto mode sets the cycle time as the longest axis sequence in the power group. This is best shown with this project. Here you can see the x-axis has a 4-second sequence. The y-axis has a 4-second sequence. And the z-axis has a 5-second sequence. Therefore, the auto mode sets the cycle time as 5 seconds, based on the z-axis, which has the longest sequence. Each time any axis sequence is changed, the cycle time value is recalculated automatically. What happens to the x and y axes from 4 to 5 seconds? That is, how does the program deal with shorter sequences? There are two possibilities: maintain last state and repeat. The default is maintain last state, which means whatever the axis is doing at the end of its sequence, that state is maintained to the end of the cycle. Let's look at the x-axis sequence. We are looking at the x-axis position, velocity, and motor torque profiles. Notice the chart is grayed out from 4 to 5 seconds. This is done to show this portion is not part of the axis sequence. Rather, it is a computed section based on the shortest sequence rule to maintain last state. The x-axis is doing nothing at 4 seconds, and there is no motor torque, so it does nothing to the end of the cycle. Now, let's look at the y-axis sequence. The y-axis is a vertical axis, and so, at 4 seconds, it has a motor holding torque of 4 Nm, which is continued on to the end of the cycle. And finally, let's look at the z-axis sequence. First thing you will notice is that there is no grayed section in the chart, and at the bottom it just shows the sequence time of 5 seconds. This axis sequence equals the cycle time, so there is no shorter sequence to be dealt with here. Finally, let's look at the power profiles chart. Here you will notice that the y-axis inverter has a small 11-watt power drop from 4 seconds to the end of the cycle, and this is for the 4 Nm motor holding torque we saw in the y-axis sequence chart. Now let's look at how cycle time affects the motor RMS torque. First, let's look at the motor RMS torque calculation. Here we have a velocity profile in blue and the resulting motor torque profile in green. And then to calculate the motor RMS torque, we use this formula. This is a standard formula seen in all vendor motor sizing rules. However, the denominator of the formula is really the cycle time, so let's write it with cycle time in the denominator like this. So, if the axis sequence torque profile is the same, then the numerator does not change, and if only the cycle time changes, then only the denominator changes. So if the cycle time increases, the RMS torque decreases, and if the cycle time decreases, the RMS torque increases. Sometimes, when the user changes the axis sequence to be shorter or longer, the motor RMS torque does not change. This occurs when there are multiple axes in the project, shorter sequences equal maintain last state, the changed axis sequence is shorter than the cycle time, and all the user did was change the dwell time in the sequence. So, if the cycle time did not change, and there is no change in the torque load on the motor, why would the motor RMS torque change? It doesn't. Remember the RMS torque formula. So in our current project, the y-axis has an RMS torque of 14.5 Nm. If I change the y-axis sequence by adding a 1 second extra dwell, that changes nothing to this project as the sequence time increases to 5 seconds, but the motor RMS torque is still 14.5 Nm. Now if I extend the y-axis sequence by an additional 10-second dwell, then its motor RMS torque is reduced to 8.8 Nm. And this is because the cycle time increased to 15 seconds. And with the 15-second cycle time, there are corresponding reductions in the X and Z axis motor RMS torque values as well. So by changing one, this shows how the cycle time auto update feature works. Let's see how cycle time manual mode works. I'll begin by reloading the original project. Now I will change to cycle time manual mode and set the cycle time to 3 seconds. The RMS torque, mean speed, and average power calculations all increased because the cycle time decreased. But what is really going on? The y-axis sequence is still defined for 4 seconds. In this case, when the cycle time is less than the axis sequence, the sequence is not changed. For example, the numerator in the RMS torque formula has not changed. Just the denominator has changed because the cycle time changed. Use cycle time in manual mode to perform quick scenario analysis for different cycle times without having to change axis sequences. This is not 100% accurate because to achieve a faster cycle time, this usually means higher velocities along with higher accel and decel ramps. That said, cycle time manual mode is a good first step to see if pushing the cycle time faster is workable before going ahead and adjusting all the axis sequences in the project. Now let's look at a different scenario when we set shorter sequences to repeat. I will reload the same project. The y-axis sequence is 4 seconds and the motor RMS torque is 14.5 Newton meters. Now I will add an additional 20-second dwell to the z-axis so the sequence time is 25 seconds. Now the cycle time is 25 seconds. Looking at the y-axis sequence, we see its 4-second sequence with an extended dwell to 25 seconds. And the motor RMS torque has changed to 7.26 Newton meters. Now I will set shorter sequences to repeat. Looking at the y-axis sequence, we now see its 4-second sequence repeating 6.25 times. Of course, this affects the motor RMS torque calculation, as well as the mean speed, gearbox nominal torque, inverter, and in-feed average power calculations. In this case, we simply have the y-axis repeating its 4-second sequence, which increases its motor RMS torque of 16.55 Newton meters. The cycle time and shorter sequences topics are explained in detail in the help file. To load the help page, put the mouse cursor on the cycle time input and press F1. It covers cycle time auto and manual modes, as well as shorter sequences, maintain last state, and repeat. This concludes the tutorial on cycle time. Thank you.